All right, in today's video, we're going to cover section 6.2, which is trigonometry of right triangles. Our first question here is to sketch the right triangle with acute angle theta, where tangent of theta is equal to 5 over 6. Find the other 5 trigonometric ratios of theta. So I've gone ahead and sketched the triangle here. It is a right triangle with an acute angle theta, and so I've drawn that in, and if I mark theta over here and tangent of theta is 5 over 6, that says the opposite side is 5 and the adjacent side is 6. So I've went ahead and drawn those in. To start figuring out the other 5 trigonometric ratios, we need to know what the hypotenuse is. So of course we can use Pythagorean theorem for that. So that is 5 squared plus 6 squared is equal to c squared, or in other words, 25 plus 36, which is equal to 61, is equal to c squared. This implies that c is equal to the square root of 61. So I'll go ahead and write that here. Once we are done with that, then we need to fill in what the other 5 trigonometric ratios are. So we've got tangent. Let's fill in cosine here. Cosine of theta is adjacent over hypotenuse. Well, we fill this in relative to the angle theta, which is here. So adjacent is 6. Hypotenuse was the square root of 61. And so we've got the cosine of theta. Similarly, we have sine of theta is equal to opposite over hypotenuse. So this will be 5 over the square root of 61. We can keep going. We have 5 more here. So let's do secant, which is 1 over cosine. So that flips the hypotenuse and the adjacent. So this is now hypotenuse over adjacent. So that is the square root of 61 over 6. Cosecant is 1 over sine. So that just swaps the hypotenuse and the opposite. And this is now square root of 61 over 5. And cotangent is 1 over tangent. Tangent was 5 over 6, so cotangent is 6 over 5. And very good. We've got that one done now. And those are relatively straightforward. So as long as you remember what cosine, secant, sine, cosecant, cotangent, and tangent are relative to adjacent, hypotenuse, and opposite sides, then this is really quite simple. We got one more question here for this section, and that is number 2, which is solve this right triangle. So we're given a right triangle, and we are told that one angle on that right triangle is pi over 6, and the adjacent side to that angle is 70. So we want to solve the right triangle. Solving the right triangle means find all of the other parts of the triangle. We know 2 angles in one side, so we want to find the other 2 sides and that third and final angle. I'm going to start by finding that third and final angle here. We can do that by first adding up the angles on the inside that we know so far. 90 degrees is the same as pi over 2. And so we have pi over 2 plus pi over 6. That is the same as 3 pi over 6 plus pi over 6. Which is 4 pi over 6, or in other words, 2/3 pi. Well, the total sum of the interior angles of a triangle is 180 degrees. Your angles of a triangle is 180 degrees, which is the same as pi radians. So, to find this third and final angle, we take the total of the inside, which is pi, and we subtract off the angles of the other two, which was 2 pi over 3. We calculated that already, which leaves pi over 3. So this angle here is pi over 3. So we found our third and our final angle. What's left is to determine these two sides. Let's start with the hypotenuse first. We can notice that if we deal with this angle pi over 6 and the adjacent side and the hypotenuse, then if we're going to use adjacent hypotenuse, we want to use cosine. So cosine of pi over 6 is equal to adjacent, which is 70, over the hypotenuse, which I'll label with an h. If I solve for h here, we get h, multiply by h on both sides, and then divide by cosine of pi over 6. So we get h is equal to 70 divided by cosine of pi over 6, which is 70 over, cosine of pi over 6 is the square root of 3 over 2. If you haven't gone and memorized the unit circle and all of the associated angles and cosine, sine, tangent, all those types of values for each of those angles on the unit circle, I would suggest you go back and do that now. You can look at section 5.1, which I know isn't something we covered specifically on with homework or in this class, but that is a section you should look through before you continue on with section 6.2 and the rest of this chapter. But anyways, if you go back and look at that, you'll recognize that cosine of pi over 6 is the square root of 3 over 2. If we simplify this, that is the same as 140 over the square root of 3. All right. So we have the hypotenuse now, right? So that fills in this part, 140 over the square root of 3. We have a couple of options. We can continue with this, or we can use Pythagorean theorem to find this third side. I want to continue with this same idea. So I'm going to use sine of pi over 6 now is equal to the opposite side, which is what we're looking for. And that is divided by the hypotenuse, which we just determined was 140 over the square root of 3. If I want to solve for the opposite, I need to multiply by 140 over the square root of 3 on both sides. So if I do that, I get 140 over the square root of 3 times sine of pi over 6 is equal to the opposite side. Well, sine of pi over 6 is 1/2. So we get 1/2 times 140 over root 3. So that is 70 over the square root of 3. And that would be our opposite side. So that's this over here. So we found our other two sides. And we've solved the right triangle. We found all three angles and all three sides. So that's it. All right. And that is all for this video.